In this section, we want to look at using sum and difference formulas. There are some additional identities that are very helpful in evaluating certain trig functions. They're called the sum and difference formulas. You really need to learn them because you'll use them in other courses. Notice I didn't circle the tangent because we can always find it using the sine and cosine. As I said, these are quite often used in courses like physics, so you do need to memorize those first four. Now, one of the most important uses is evaluating a trigonometric function. So let's take a look at one of those. So suppose we know that the sine of u is minus 3/5 and u is in quadrant 4. The cosine of v is 15/17 and v is in quadrant 1. All right, so u is in x equals 4, y equals minus 3, and r equals 5. In v, oops, I meant to say x. So the sine of u minus v will be the sine of u times the cosine of v minus the sine of v times the cosine of u. And being very careful with our arithmetic, minus 45 over 85 minus 32 over 85, or minus 77 over 85. So you will notice there that we do have a negative number and it's less than 1. If it had come out greater than 1, we would have had a real problem. All right, let's get ready here. All right, let's do another one here. Tangent of u plus v equals minus 3/4 plus 8 over 15. In other words, we found the, and the other one we found, I believe, the sine of u minus v. Now we're at the tangent of u plus v. So substituting into that formula that was on the first slide, and hopefully you've copied them down somewhere. Being very careful of your arithmetic here, because otherwise we get in a bind. We get minus 13 over 84. The cosine then of the arc cosine of x minus the arc tan, here's another application. We've got the cosine of the arc cosine times the cosine of the arc tan plus the sine of the arc cosine times the sine of the arc tan. Now, here's where you use this little triangle, right? Because we know certain things, and so we will use our triangle here to get the other quantities. This one's hard. You may need to stop the video and back it up and see what we're actually doing here. This one is hard. I wouldn't put one like this on a test. All right, we've looked at the first thing. Now, these will also be used to verify a cofunction and derive a reduction formula. Let's try an example of doing that. So the sine of x plus pi over 2, you see, will be the sine of x times the cosine of pi over 2 plus the cosine of x times the sine of pi over 2. Well, we know that the cosine of pi over 2 is 0, and so we get that sine of x plus pi over 2 is the cosine of x. Let's try the sine of x minus the pi over 4. We would be doing it exactly the same way. In this case, we could factor out a square root of 2 over 2, and we end up with the sine of x times plus the cosine. All right, these can also be used to solve a trigonometric equation. Now, this might be one of the more difficult things that we would try to do. All right, let's work a problem where we need to use one of those sum or difference formulas to solve it. So let's expand the cosine of x plus pi. And look at your formula page, you'll see what I have there. Cosine of pi we know is minus 1. Sine of 0, or sine of pi, I'm sorry, is 0. So what do we have here? minus cosine x minus 1 equals 0. Minus 2 cosine x minus 1 equals 0. Minus 2 cosine x equals 1. Cosine x is minus 1/2 in quadrant 2 and quadrant 3. So we have 2 pi over 3 and 4 pi over 3.